confidence interval for a chi-square. A 95% confidence interval. Now, before we start this, what does this represent? The variance. Good. This is the variance from the sample. With me? Alright, so the first thing we're going to do is go to your table, and we have to find the values for x2L and x2R. So we look up degrees of freedom. What's my degrees of freedom? 29. We start like your inverse norm. We say 1 minus 0.95, divide by 2. We do this first. We get 0.05 divided by 2, we get 0.025. Subtract it from 1, we get 0.975. On table 6, you go across the top. It's symmetric about the middle. 0.025 and 0.975 come down to degrees of freedom 29. Find your point. Find your critical values. If you don't have a table, it is on page A19. A19. Let's pull the numbers off for now. Anybody get one of them? 16.047, and what's the other one?
45.
Okay, so now, the left one has to be smaller. So this is 0.047, this is 45.722. We know our critical values. That's the hardest part of the whole equation. Then, to find your interval, we took your degrees of freedom, we took your variance. If we have your variance, we just slide this in here. If we have your standard deviation, then we have to square it. And we put this over x2r, the larger one. And the numerator for this guy is exactly the same. So your degrees of freedom are 29. Your variance, and we don't have to square this because it is squared, see it? If it is squared, we don't need to square it. S squared. If it's not squared, standard deviation, then we need to square it. But it's squared, so we don't have to square it. x2r, take the larger one. You're building a variance, same numerator. Hopefully this is coming back to you. And then the smaller one. This fills your variance confidence interval.
How many places is it on?
You generally like 3. Because what happens with this too, your standard deviations, you could probably go 2. But generally 3, because this builds the whole thing together. There's no plus or minus in this.
I would like to always divide by the bigger one first.
Yes, because you want your inequality to be smaller to larger. If by accident you did it the other way around, when you look at your inequality, you're just going to swap them around. It doesn't do anything bad. It'll just, this number will be the larger, this will be the smaller, and then you'll just have to swap them out. This finds your variance. That's length. And you can go 2 decimals, 3 decimals, what did I say, 3 decimals? So what did we get? 7 point.
This will give you this.
This is for your variance. To where?
20.
I'm sorry, say one more.
20.89.
Thank you so much.
You don't square.
No, because that was the variance. That was squared. If it's squared already, you don't have to square it. Let me go through this and then I'll make believe it's a standard deviation and show you the difference. Now, this is your variance confidence interval, square root. to get your standard deviation confidence interval. You take the square root of each one. There's no
Are
margin
we using
there.
the whole number or the rounded?
You can use this piece right there. It's technically nicer if you use the whole one, if you catch it before you put the next one in to do second answer. That works nicer, but if not, this is fine. That's why I like to go 3 decimals, because you get a little margin of error in your rounding.
I'll still round it 3 decimals.
3 decimals. So what'd you get, Damani?
2.78.
Thank you. And this guy?
That's 4.571.
571. Oh, right. Okay, so that's your confidence interval. To be 95% confident that your population variance, they didn't give us a scenario, so your population variance will fall between 7.332 and 20.891. We can be 95% confident that our population standard deviation, therefore, will fall between 2.708 and 4.571. Now, if you reverse these, you would see the 4.5 over here and the 2.2 over there. You would just swap them out. Now, how is this different from a variance? If, in fact, they gave you a standard deviation of, say, 3.9. They took the square root of this, I don't know what it is, but 3 point something or other, right? If you put that in here, this is not squared. This is squared. So you would have to then square it.
Just gotta make sure you're paying attention.
You just got to make sure you're paying attention. In the words, it's a little harder because you're going to see variance. They showed us this by symbol. So we see the square. In the words, this will say variance, which we will know that's already squared. If it says standard deviation, then we know we have to square it to get the variance. Like in your calculator. When you do 1 var stats L1, you get your standard deviation. You do 1 vars to statistics, you take your standard deviation, you square it to get your variance. No difference. Alright, so you do the next 3. Okay, number 14.
The square root of 2.
This is a great example. Look at the difference in how little these vary, guys. Look at how small they vary. Some of them vary just at the hundreds and the thousands places. Their level of their cough medicine's measured. You can't give someone too much, or they're overdosing on this, or you can't give them not enough, or it won't be effective. So anything medical is measured with variance a lot, because this is where we measure something so small. We put this in your L1. You pull off your SS. This is your sample standard deviation. You can't use your population one because you only know a sample.
So what's this one? We're doing a 6.4, right?
Yes. You want a 95, what do you want, a 90% confidence interval? So you subtract it from 1 divided by 2, just like you do your inverse norm. All your inverse norms works like this, whether it was a t, a z, or a chi-square. Start that way. This one goes to the table though. Find your degrees of freedom, pull out your values. Your L is the smaller one, because normally your chi-squares go this way from 0 to infinity, but your larger one goes on the left-hand side. Question? Oh. Good. Everybody okay with this? Now, because you found your standard deviation, you have to square this guy. Question?
No, you only block 3 decimals.
You can do 3 or 2, whatever you.
When you square it, what you get?
I just did it in the formula. I did it in my calculator. Just let your calculator do it. I might just happen to go out a lot of decimals on these, but you have to at least go out to a significant. Okay, what'd you get?
I got 0.032 and 0.045.
0.032 and 0.045 because you only rounded to here.
Yeah, I got 0.0005 for that.
0.05. Oh, did you take your standard deviation up here first? Well, you probably just went out like 2 decimals.
I got 2, 2,
So
3.
you should have gone at least 3 decimals on the standard deviation.
Yeah, I didn't get your answer.
Yeah, I didn't get your
I
answer.
did
I got
4.
close to your answer, but I didn't get your
As long as you show me your work where you're rounded, it's all in the rounding.
2, 2, 3, and 4, 5.
Yeah, that's fine.
I plugged the simple variance right into the equation instead of doing it that way.
Yeah, that's what I'm saying. You squared it first and then plugged it in.
14 times 0.0001.
Right, because
Yeah,
you
that's
squared
what I
it
did.
first.
That's
So,
what I did.
yeah. It's probably a little bit better to put it in your equation and then square it, but that's fine
I
too.
got a slightly different answer.
And that's fine. It's just in the rounding. It's within a good reason. A lot of you were getting this 5.9 something or other, e negative 4. Remember, this e means 10 to the negative 4. Move your decimal 4 positions over. It's got to be real small. Where are you? Yes, this one's being switched over here. No, this is right.
You got it opposite of that.
You're supposed to divide by the larger number. This guy should be over here.
Yeah, that's what I mean.
That makes a big difference. Guys, don't pack up. We have 7 minutes. How did you divide by a larger number and not get the right answer?
We got the same.
Lose track of why we do this. We don't know the population. We only know what we gave and what we have in our sample. So we can be 90% confident that your population standard deviation will fall between these two numbers.
So it's okay if we're just a little bit off.
Well, you'll be off because if you rounded before you plugged it in, or if you rounded to different decimals than I did, you'll be a little bit different than me. But you'll be in the ballpark. I'll follow your rounding all the way through. Try to make sure you keep it to at least the significant digit. These are going to be smaller than normal. A variance is always a little bit tougher to see in the beginning, but most of the time we use your variance for the little tiny differences. This one's a little bit more obvious because look at how big your standard deviation is. You have a standard deviation of 109. You want to be 80% confident, so you're looking up a 0.10 and a 0.9 and plug them in. See where you went wrong.
I still
They gave you a standard deviation. You have to square it. If you squared it before you put it in, that's fine. This one should be a little less problematic because there's no decimal. You got to square it. Yeah, if they give you a standard deviation, you have to square it. Because what happens in the words, you don't see that standard deviation is just an S, right? You need to get it to be squared. Questions? It's looking good? Okay, and last one. They gave you a little graph there to take this from. They gave you N, they gave you your S. Again, you plug it in. Good? Now, tonight, you need to do this homework. Tonight. No, I said tonight. Some of these are just easy as looking up or just finding a point estimate for a proportion. Some of them just say find a p-hat. Some of them just say find a chi-square.